Yeah, thank you, Patrick. My name is Lars König, and with me there's also Sumer. Sumer, you're there?
Hi, good morning, everybody.
We are running the show from our homes in India and in Germany, and just my postman came and put some parcel there. That's live. So we're gonna speak about the benefits of a unified architecture. Before that, maybe a few words about ourselves. So we are a new Qt service partner from the beginning of this year. Verolt is a company based, headquartered in the UK, and much of development is being done in India, and that's good. We have three main service lines, being ECU development, HMI, and mechatronics. But we're only talking about our HMI capabilities and service line. And that's something so Suma and myself, we are running the show here. I said we're developing a lot in India, but we have a lot of experience also on European market. Our DNA is largely to that. I have been for Qt for a few years, working for other companies for about 20 years. And Sumer and Ravi, who is also with us, they have a long history on European OEMs, Bosch, Magneti Marelli, TES, etc. So management is largely to the European market, the history. So that's our few words about our company. So we are massively ramping up. We are at the moment around 15, 16 developers in the HMI business, and we are also aiming for more this year. Certainly the coronavirus may slow down things, but that might be the case for many others as well. What is our focus area for the HMI business? We once created that slide here, which tries to explain that. So we're aiming to optimize the code and design and code pipeline, and that's why we are Qt partner, right? So having the best framework, limit the use of too much technologies, reuse designs, and being agile, iterative. That's the Qt thing where we are. We're also looking into reuse components across use case platforms. That's something we do a little beyond, and we actually launch many of those components also in the Qt marketplace soon. So there are ideas of calendar, for instance, something that many customers might need, and we will share that via that channel. But we also focusing, and that's the third thing, to optimize the software for all platforms, the best OS expertise, being future ready and proven. We have in-depth expertise on middlewares and OSs like Yocto, GStreamer, etc. Of course, our mission is to streamline product development, make it more efficient at the end, and therefore being able to foster product information for our customers. Let's go into the main topic of today. So why is it so difficult? Why is what so difficult? So the software development, there is, so I put it here that provocative in a sense, and on the R&D side of the view and the business side of the view, the R&D guys, they usually have an idea of the structure of software code, protecting the IP, making things efficient, having all their own agenda and priorities, etc. On the other side, the business, there's also an idea of structure things and entities, business units and whatnot. And they have also certainly in their priorities on the business perspective. How translates that into cooperation? Certainly, yes, there is a process being developed over the last, 50 years. Today, largely being agile, being translated from epics, user stories, use cases, features, platforms, operating systems towards the deployment, which is then the delivery to the business or to the company. As such, that's a good process, right? So, but it wouldn't be quite simple if that would be everything. So along that way, along product development, there's many questions to be answered, which are key questions, and they are on-off questions. So you decide for something and then you might stick into that, like whatever you focus on rather being cost effective, or you focus on being quite valuable from the beginning. You focus on technologies like, yeah, we going to do web, or we going to do native, we're going to do it online or just offline. We just do it via the cloud, or we're just doing that on the edge. Hard decisions. And the point is, usually life changes and software development changes. There's always a change, and then you encounter these problems again. You have that one day, and that's actually the problem. Change is a given in software development, and from our perspective, a unified architecture is, on the one hand side, being ready. Yeah, it's a thing not only to be developed good for your current setup, but also being ready for change. And today we talk about two scenarios or two ways of doing unified architecture. One is being the today's state-of-the-art architecture, and the other one is kind of future looking. Also a little bit provocative, saying, hey, let's talk about how the future would look like. That's pretty exciting. Stay tuned and keep your attention, please. We know how it is on webinars. I will certainly also increase a little bit the pace of my speaking. Okay, our consumer electronics demo we developed last year. It's the first unified architecture demo we have built, and that's something built with Qt, built with certain technologies. I get into that first in a second. And you can see here, so we deployed from the same code base into 4 scenarios, or 4 deployment scenarios, being embedded, being desktop, web, being mobile, and being MCU. And use cases we put here is a recipe book, a meal plan, a shopping list, a cooking mode for the embedded device, YouTube videos for the embedded device, and remote streaming or in nutrition overview. That's the use case perspective. And all built with Qt. We utilized Photoshop in Design Studio. The embedded was an IMX6. The MCU was an STMicro device. We deployed to Mac OS and Windows. We deployed to iOS and Android. Actually, we also deployed to WebAssembly. Web Engine has been used on the embedded device to stream YouTube videos. WebGL plugin has been added to the embedded device to stream camera output to remote clients. We use MQTT heavily on all deployments to do the connectivity part. And we had also local and remote brokers, MQTT brokers for the data center database. Also serving everything via a web server. That's the unified architecture scenario. The first one. We have been working on further ones since then, but that's still our flagship idea of a unified architecture. That's how it's looking like. So from the real photos, you can see that here. That's a desktop WebAssembly and the STMicro and the embedded device. Just to give you an idea about the functionality, I just show you the WebAssembly application, and here you see the WebAssembly application as as not a website. I think that's the first and only purely Qt-based, Qt WebAssembly-based web application, which really gives you an idea of how a web app built with Qt could look like, right? So there's everything what you would expect from a website is being also part of that. So even a tablet mode here, so and nutrition, so there's a Qt charts being used, and also design animations with Qt Design Studio made. So that's the idea. So from the idea to the question is how we did it, and maybe Sumer, you speak briefly about that, right?
Yeah, thanks, Lars. Just requesting control over the screen.
I can.
Thanks. Yeah.
Do that.
Great. So thanks, Lars. So as everyone just heard from Lars, so we developed the Home Chef application on a wide range of deployment scenarios, right? Right from the main scenario being on the IMX6 and which simulated a cooking machine to having the shopping list sent on to the mobile applications to having everything being available on desktop and WebAssembly, and later we extended the application to an MCU as well. So there was a considerable amount of development from our side, and of course some learnings from our side that around the unified architecture. So we decided to put our points down and share it with you. So these are our consideration sets that Lars, you might just have to go back one slide. Yeah. So basically the first 3 points are more on the separation between UI, UX, and business logic. Yeah. So the separation of concerns is something from in a unified architecture that needs to be well addressed during the architecture phase. Keep your UI light and stick to the model view controller or similar principles to drive the UI and data. So we also believe that UI centric applications need to be kept light. At least the GUI threads need to be kept very light, and therefore move heavy lifting to other processes or other threads. So the unified architecture also helps one parallelize activities. So you can develop your UI and your business logics from a software engineering perspective rather independently. And from an architecture and design point of view, do consider different deployments early, very early. Consider different screen resolutions, different pixel densities, as well as different layouts that you would have to deploy on. Yeah. So keep the engineering process iterative and have a good stakeholder binding into the software development. So Lars, the next slide, please.
I don't know if you might control that as well. But
okay, thanks. And so for the Home Chef, I give a quick overview of the product architecture. So what we had a number of considerations to have, and we feel that this would resonate with you because in your product journey you would also have to consider all this. So from a design point of view, our input was Photoshop, and we then accounted for different layouts for different deployments, and developed assets, UI assets, its components, and as you saw from Lars's demo, we then composed the different screens, the shopping list, recipe book, and other screens. Yeah. Yeah, when you look at a deployment scenario, for us it was largely embedded, desktop and mobile. The embedded story further bifurcated into Linux and the microcontroller, and I also share a hint of the toolchain complexity that we also had to deal with. So for embedded Linux, it's Yocto, and then for MCU, we had to deploy on bare metal as such. Yeah. And from a desktop point of view, we had, of course, deployments of desktops running on Windows and Mac OS. But the WebAssembly demonstration that you saw on desktop used the Emscripten toolchain that we'll talk about more as we go forward. Yeah, so a lot of screens to be considered and a lot of functionality to be considered in applications, right from splash screens to your different menus and screens, and this is a list of most of the functionality that we considered in the Home Chef. Yeah, and then comes to different libraries and frameworks that you use. As Lars mentioned, this was a showcase of the Qt framework from our side and its abilities, and we used Qt over with of course its generic framework for through C++. Then we also had the desktop libraries use WebAssembly. And for embedded, we of course had to use Web Engine for showing the YouTube content, WebGL for remote streaming, and Snips for the voice activation part of it. And MQTT is another library that was used across all the deployments for communication with the external world. So how did we stitch everything together in all those apps? So I give a quick overview of both the way the architecture was segregated or the concerns were segregated in the architecture, as well as the tools that we used. So starting from the left-hand side, so we have, of course, the Qt Design Studio used to compose our screens, our components, and our animations in QML. And we followed, of course, the MVC pattern, and in the middle, you can see on the top side the QML components and property bindings. This essentially acts more like a controller in this scenario. And then you can see the business logic and the C++ Qt framework acting as the main model here, right? And driving the front end. So that's what we try to highlight a lot in our architecture, that the backend needs to drive the front end. And then, of course, a lot of platform-specific adaptations to be done, and that results in different deployments. So good, Lars. I give it back to you.
Yeah, no problem. So doing that is certainly doing that in a unified architecture. I suppose many of you have the idea to do it in the same way. And there are certainly strengths and opportunities and whatnot doing it, right? So what we thought of, hey, maybe we summarize that. Gives you also some food if you need to justify things. So from our perspective, doing that way, there's quite some strengths. For instance, you need less skill sets. You don't need any web developers, for instance, or web development skills. You might be able to increase the performance on all deployments at the same time if you optimize something. It reduces testing efforts and you being able to parallelize development. That's certainly a strength. With that, you might have certain opportunities moving forward. So you can certainly protect your IP, even if you do need to do it somewhere, somehow differently in the future. If you really encapsulate your IP into modules, then of course you can reuse that. So you'll be able to overcome technology gaps, keep vendor independence, and overall being faster and more innovative. So there's certainly also some weaknesses coming with that, like some front loading, additional development would be needed, development time would be needed. Certainly something like strict execution and discipline for development teams is needed. And if you have legacy products, of course, refactoring might be needed as well. The risk with that, so there is certainly a risk if you go into that way. So if you have in one way or the other critical errors, it may block general progress, or unconsidered or new platform-specific aspects may block development as well. That's something to be considered. Or there's also the general concern of over-engineering of either is very simple or a very big project. With that, we also thought of, hey, what are the recommendations when to do and when not to do, and we thought of, hey, what are the KPIs to do a unified architecture, like whatever at the team size or product complexity, etc. But at the end, we came to the conclusion that it's always good to aim for a unified architecture. But there's always a risk to deviate from that, and there might be risks which are just in a given, whatever, you're in a rush or the team size is just being too big. There might be also teams that have not enough experience on that. So there's always a risk with that. And of course, at the end, you need to balance that on your own. So certainly you know your setup best and decide if it makes sense to go for a unified architecture or not. That's the first part, and now I'd like to hand over to the, let's say, more to the future scenario, and it's going to be a discussion about deployment. So if you have a unified architecture like our Home Chef version, you can deploy that in different ways, like just a single process. It has pros and cons. It might be highly optimized. At a certain point, it might be difficult to maintain. There are more risk on security, and of course, you need to decide on the programming language. It's polyglot, so it's not polyglot in the sense that it's just being one programming language being used, or compiler chain. The other part is, of course, you can just do it pure vertically. So we haven't done that yet at this product, but that's also possible. We have seen these kind of setups for some certain industries, really big ones, where we need to incorporate the technologies from other third-party vendors, and so on. That's also an option. It's highly independent. It's certainly easy to secure. You can decide also for different programming languages, and containers are quite often used. Mixed scenario, which is pretty popular, is you just do a front end, you have core IP somewhere in the middle, and then you have a back end connection to manage the connectivity part. All of those have dependencies, right? And that's the point. And you need to deal with these dependencies. And what if you could overcome these dependencies if you would use WebAssembly on all platforms? And that's now the future scenario we are looking into, using WebAssembly as a common deployment scenario or deployment vehicle for your code. And we think there is an opportunity, and I'd like to introduce that briefly. So there's two main aspects to know about WebAssembly. One is being known inside the browser. WebAssembly is also a modular thing to being able to grant access of resources and APIs. The history is from Google native client and Asm.js, C++ compiler to JavaScript, and that has come together. The main compiler tool chain is Mscripten and LLVM backend to support WebAssembly. That's the history, and that's being used in our Home Chef version. But there's a second one which has been announced, or I think 2 years back, it's outside using WebAssembly outside the browser. And for that, there's another standard coming, which is WASI, WebAssembly System Interface. And just to give you an idea, the WASM, so the WebAssembly thing, is to build for a conceptual machine. It's a bytecode which needs to be compiled to your machine. And VASI assumes a conceptual operating system. So in a sense, VASI is VASM, all VASI is VASM, but not all VASM is VASI. So that you need to consider if you think of VASI as something on top of WebAssembly today. So it's a sandbox, it's portable and secure, and there's a module-based, standardization process ongoing. A little bit of milestones on WebAssembly. So as said, native client and SNJS came together in 2015 roundabout, and the first WebAssembly application has been built, the Unity Angry Birds. And from that, there was quite some silence until 2017. And then large milestone has been Chrome and Firefox as an MVP being supported. A year later, roundabout, this WebAssembly system interface has been announced by Mozilla. We have seen more compiler and runtimes coming. There's a Lucid one for a cloud scenario. We saw recently also Microsoft looking more into that with C#. And what you can see is that, so what we have noticed that Lucid and Byzantine, that these are the most popular runtimes, they have decided to go for joint forces. And there's also, at this point in time, 40+ languages being supported for WebAssembly. So that's the history, and we believe there is, so what we notice, there's certainly some momentum, and we hope the momentum goes on. So if you think of WebAssembly as something getting mature over time, and how it relates to other ways of doing it. And I try to put it a little bit into a table, which comes in a second. But before that, so also statements of people like the Solomon Hykes, the Docker's founder, said, hey, if WASM and WASI would existed in 2008, they wouldn't have the need to create Docker, right? So there are certainly people, important people, who believe in that technology and push it forward. So, and we put it in this table here, and just to give you an idea, certainly, so that's the table is about how relates WebAssembly about other deployment possibilities, like doing it in HTML5, JavaScript, doing that on a processor natively, or doing that on MCU natively, or as a cloud container approach. And certainly WebAssembly is not mature, not yet mature enough for against all of those. But if it would get mature, we would see actually in many aspects it would outperform other approaches, like polyglot can use whatever programming language you want, and then you can go for that in these scenarios. Or the performance, it would outperform HTML5 and JavaScript. It's already doing that today, right? Or we already see it outperforms container approaches. So there's a security aspect coming with that, which is also outperforming. So in a sense, we believe it's just a matter of time until WebAssembly is really getting something where it's will be out ahead of the competitive approaches. So, and how difficult can it be? And that was always my former manager asked me and say, hey Lars, how difficult can it be? Of course, it depends, right? So it's if there are no really roadblockers, then it's just a matter of time and doing it. And here's another statement from somebody who's pretty important, the co-founder of Xamarin. He's also believing in the incredibly exciting space of WebAssembly and many opportunities. And we just thought of that, if you think of that, right? So if you would use WebAssembly as to build your website. So you would use WebAssembly to the very same deployment for bootstrapping on whatever native formats, MCU, desktop, or embedded, or you use the same modules on a server, then it's just a matter of plugging that together, right? So, and maybe it's an old dream of ubiquitous computing, or it's a more recent dream of this edge computing thing. But I think with WebAssembly, we could get closer to it. And there are actually, from my perspective, nothing which speaks against it other than the maturity. So at the end, that would be modern in the sense that it secures, it's secure and it's performant, and it's also sustainable from the footprint and overhead perspective. It's quite flexible. It would be polyglot. You can decide whatever programming language you want to have inside, and it would be also universal. Kind of nice future. I would love to see that. And if we go back, if you think of the scenario at the beginning of what are the hard decisions, and if you would have something like that in place, then it would be quite easy to change directions in development phase if you have kind of setup which looks like that. I'm now coming more towards the end. So if you're interested into WebAssembly and the technology, certainly you can just reach out to us. There are a few articles we would really recommend. The first one is giving you quite an in-depth overview about the concepts. There's a Mozilla standardization activity about the WebAssembly system interface. And there has been a WebAssembly conference, and I think January this year, with a lot of talks, which are all available at YouTube. There's one last thing we have as well. We are looking for ideas. We want to, as our Home Chef version was already a good thing of demonstrating that unified architecture, we want to extend that. We want to extend it with Qt. But we also want to extend it with WebAssembly in different scenarios, like towards the embedded usage, towards more desktop usage, or many deployment scenarios at the same time, or perhaps also nice features to showcase. So if you have anything in your mind, being that from a new project or a legacy project, we could work on that jointly. We like to invest into that, and perhaps we might be able to showcase that in the public one day. So if you have an idea, just come back to us, and we could have a conversation about that. We would love to see that. That's all from my end. Sumer, anything from your end? Have I anything forgotten?
No, Lars, I think you've covered it well. And while you were talking, we had a look at the questions as well. So
okay,
perhaps we can start with the questions. Few of them have been answered, but we'll still perhaps run through the questions and the answers.
Yeah, go for it. That's good.
Okay,
we have about 3 more minutes to till we have to go on to the next one.
3 more minutes.
Yeah.
Okay. Good. So I start maybe with the first question, which was, is the web user interface built with Qt2? Yes, the entire WebAssembly application is built with Qt. The same QML was reused for WebAssembly. In the WebAssembly, do you use a data server? How's the communication with the backend done? Yes, we deployed it on a server, and we used Qt MQTT over WebSockets. Yeah.
And Mosquito MQTT broker.
And yes, and a global Mosquito MQTT broker. There was a question on how does your continuous integration pipeline look like, because there's so many architectures, then making CI extremely hard to test. So my colleague Ravi has given an answer here. It says that the combination of unified architecture and Qt provides a big advantage to manage CI activities. Yeah. So I'm not sure if this completely answers your questions. If it doesn't, please just give a hand out and we'll just come back to it. How are you using MQTT? We use it with Qt MQTT. And there's one interesting question, Lars. Why use WebAssembly outside the browser?
Yeah, it makes you just easier, right? So if you would just use, of course, you need to, if you want to exactly reuse the same module on different scenarios, you just need to compile once, right?
Yeah. Why have you decided to use Qt and not other frameworks such as Electron, Iconic, etc.? They have more or less similar functionality.
Yeah, we need to demonstrate that with one technologies, right? So we are in the camp, we have a lot of expertise with Qt. We think Qt is a good technology and also pretty reliable towards the market. We know that many those looking into that, that's for us a good reasons enough to do it like that way.
Yeah, I would like to add some point on the last comment actually. So if you see our home chef scenario, so we had an embedded device, then we had the phone, mobile environment, as well as the web and PC environment. So all these environment are very well supported by the Qt framework. And we have to, and the platform abstraction is managed very well in Qt compared to other frameworks. So, and in terms of C++, it was giving more performance compared to other frameworks. So it was a natural choice for us to use the Qt over other framework where it was required more R&D effort, while with using the Qt framework, it was the same source code deployed multiple places. Yeah, I think.
Ravi, just one more question you may want to answer, that we also face this challenge, right? The Photoshop bridge generates screens with fixed sizes, right?
Yes.
And how do you manage scalable screens? That's also been our request to Qt, right? To kind of include this change to have maybe percentage resolutions available in the design studio, right?
Yes. So yeah. So one of the as it's mentioned in the question. So when we export from the design studio, all the values will be based on the fixed size. So we have some sort of script internally developed, as well as there is, though the script is not perfect, but we also use some manual effort for it. And yeah, with the combination of the script and the little bit tweaking, we use, so this saves a lot of time for us to generate the QML, which is scalable. So yeah, so one of our requests was to somewhere add in the Photoshop bridge to manage this scalability. So Photoshop provides a percentage value. So Photoshop bridge can really accommodate this functionality. So yeah, so yeah, I think I answered that.
Yeah, you've answered rather well. I'll just step in. Maybe if we can just squeeze in the last 4 questions. There's a question: how does the performance of WebAssembly compare to regular C++ QML code?
Yeah. Yeah. As Lars mentioned during the talk, there are certain challenges with WebAssembly. So one has to consider this WebAssembly is running on top of the browser. and it is still in the sandbox environment. It's not the perfect environment. There is a reason behind why it is on the sandbox. Is also the current browsers are giving the full security aspects to it. So your C++ code runs very well with a WebAssembly in the browser environment. Okay, yeah, but it has its own cost. So compared to standard C++, which is very native to the operating system, definitely it gives you a better speed compared to, but that speed is negligible compared to the WebAssembly.